Good morning. This is Unit 2, Day 13 notes. Today we're going to go over the double angle formulas. So this is how we got the double angle formula, sine of 2 theta. We know that sine of 2 theta is sine of theta plus theta. And we know that the sum formula for sine is sine, cosine, cosine, sine. So sine of the first one, cosine of the second one, plus cosine, sine. They're the same, so it doesn't matter. Now sine of 2 theta, these are the same terms. You can switch this to be sine cosine if that's easier for you. But sine of 2 theta equals 2 sine theta cosine theta. So we actually got this from the sum formula. Alrighty, let's look at the cosine formula. Cosine of 2 theta equals cosine of theta plus theta. Remember, the cosine formula is a little bit different. It's cosine of theta times cosine of, well, this theta. And then if this is plus, this is going to be a minus. Sine of alpha times sine of beta. This simplifies to cosine of 2 theta being cosine squared. Cosine times cosine is cosine squared theta minus sine squared theta. Cosine is actually a little different because we have our Pythagorean identities. We have another variation. So cosine of 2 theta is also, since it's cosine squared minus sine squared, and we have our trig identities, or our Pythagorean identity that says sine squared plus cosine squared equals 1. And I can solve for cosine and plug this in. So I'm going to subtract sine, cosine equals 1 minus sine squared. So cosine squared equals 1 minus sine squared. And I still have a minus sine squared. So this is 1 minus 2 sine squareds. So this is our other variation. There is one more. If I had plugged in 1 minus cosine instead of 1 minus sine, it would be one minus cosine. Use your parentheses because we have to distribute this. So we have cosine squared minus negative cosine squared, which is actually plus 2 cosine squareds minus 1. This is our other variation of cosine. Okay, it says, let's do some practice. It says, if sine of theta is 2 square root of 3 over 5, and theta is in between pi over 2 and pi. So we're just going to draw where it is. And it looks like it's in between 90 and 180. We always go down to the x-axis, never to the y. So sine is opposite over hypotenuse, so this is my theta. And my opposite is 2 square root of 3. My hypotenuse is 5. I need to use the Pythagorean theorem to figure out this side. I don't know what this side is. So give me a second. Try it out. Alright guys, I got x equals either plus or minus the square root of 13. When I plug it in, it'll make sense. Since I am substituting it into the x values, and in this quadrant the x values are negative, it's going to be negative square root of 13. Okay, so it says cosine, let's do a first. A is sine of 2 theta. Well, sine is sine of, 2 sine of theta cosine theta. 2 sine theta cosine theta. And we don't know exactly what theta is, but we know that it's right here. This is 2. Sine, we already know, is opposite over hypotenuse, which is 2 square root of 3 over 5. And cosine is the adjacent over hypotenuse. So this one is going to be negative square root of 13 over 5. So you're going to have to multiply these together and find out what sine of 2 theta is going to equal. I'm going to set up B for you also. B is cosine of 2 theta, which is a little bit different. We'll use, it's up to you. I'll just use the 2 cosine squared theta minus 1. You can use the other one of the other ones if you would like. So I am going to write down the 2. Cosine squared, I know that cosine is negative square root of 13 over 5. This whole thing is squared, and then still minus 1. When I simplify this, I have to do the exponents first. So square root of 13, not 3. The square root of 13 squared is just 13. Over 5 squared is 25. And I still have the times 2 and then minus 1. And this becomes, this is going to become positive 13 now. 2 times 13 is 26 minus 1. This one will be 25 over 25, because 25 over 25 is still 1. But we have to have a common denominator. So this is just going to give me 1 over 25. Check my work, make sure I did it right. 1 over 25. I want you guys to try example 2. Try this one. All right, this one says, let sine of 100 equal m. Find the expressions for the following in terms of m. We don't know what m is, so we're not going to be able to write it in terms of numbers. We're going to have it in terms of m. But this 100 degrees does tell me what quadrant we're in. It looks like we're in quadrant 2. This one says cosine of 100 degrees. So I know that cosine is sine. So my Pythagorean identity is sine squared theta plus cosine squared theta equals 1. And my theta in this case is going to be 100. So this is sine squared of 100 degrees plus cosine squared of 100 degrees equals 1. Now sine squared of 100 degrees, we actually know sine squares at 100 degrees, or sine at 100 degrees is m. So sine squared at 100 degrees is m squared plus cosine squared at 100 degrees equals 1. I'm going to subtract my m squared, so I get cosine squared 100 equals 1 minus m squared. And then I can take the square root of both sides. Since I'm taking it, it's going to be plus or minus, but it's going to be cosine at 100 degrees, which was what they wanted. Cosine at 100 degrees is, this can be positive or negative, but since we're in quadrant 2, we know cosine is negative. So it's going to be negative square root of 1 minus m squared. And I'm going to write a little note. This is negative. It could be positive or negative, but it's negative because we're in quadrant 2, and cosine is negative in quadrant 2. So I write a little note to yourself why we know it's the negative one, not the positive one. Let's try tangent. Tangent at 100 degrees. We know tangent is sine at 100 divided by cosine. I guess at 100. I was going to put theta, but we know it's 100 degrees. Sine, they tell you, is m. Cosine at 100 degrees is negative square root of 1 minus m squared. Sine at 200, this is going to be our double angle formula. So we have sine at 200 is sine of 2 times 100, which is 2 sine 100 cosine 100. And you guys know what sine 100 is, cosine 100 is. Just go ahead and plug it in. And we'll find 2 times something times something. It says if A is acute to less than 90 and cosine of 2A equals negative 7 over 9, find without a calculator cosine of A and cosine of alpha and sine of alpha. So this is going to be A cosine. We're going to find cosine of alpha. Okay, so I'm going to write down my double angle formula, which is cosine of 2 alpha equals, I'm going to use the one that has cosine because I'm trying to find cosine of alpha. So I'm going to use the one that has only cosine. 2 cosine squared alpha minus 1. This is my trig identity, the double angle formula that I want to use this time. So cosine of 2 alpha, they actually give this to you. It's right here. Cosine of 2 alpha is negative 7 over 9. And then this is equal to 2 cosine squared alpha minus 1. I'm trying to solve for this now. I'm trying to find cosine of alpha. So what I'm going to do is I'm going to add 1. If I'm adding 1 over here, I'm going to add 9 over 9, so it's a common denominator. Negative 7 plus 9 is just 2 over 9. Positive now. 2 cosine alpha squared alpha. I'm going to multiply by 1/2 to get rid of that 2, because it's a fraction on the left-hand side. So these 2's will cancel. I'm going to get 1 over 9 equals cosine squared alpha. And I just want cosine of alpha. So I'm going to have to take the square root of both sides, which is pretty cool because cosine at alpha is the square root of 1 is 1 and the square root of 9 is 3. Now sine of A, you're probably going to want to use the one that has the double angle formula for cosine that has sine in it. So this one I'm going to use cosine, I'm going to find sine of alpha, which is cosine of 2 alpha, oops, I'm going too fast. Cosine of 2 alpha equals, we'll use the one that has sine in it. So 1 minus 2 sine squared. So you guys can try this one and tell me what the right answer is. All right, I'll try one of these. Let's try this one. It looks kind of complicated. So this, I'm going to factor out a 2 from both. This term has a 2 in the front, and this term has a 2 I can factor out. So this is 2 times 2 cosine squared of 2 beta. This is a 2, not alpha. So 2 beta minus 1. And then I know that cosine of 2 theta equals 2 cosine squared theta minus 1. And I see this right here. 2 cosine squared. This is my theta minus 1. So I have this 2 on the outside. This is just going to be cosine of, I still have this 2, or I'm going to have this 2. We're going like the opposite way. And then I still have this 2 beta is my theta. So times 2 beta. And I can simplify this to be 2 cosine of 4 beta. I want you guys to try the other ones and let me know if you have any questions.